Hi, it's Mr. Baker here with another physics video. Today we're going to be looking at ionizing radiation. Okay, so mutants with superpowers caused by exposure to radiation are common in films and comics. Do you think that this radiation can have beneficial effects in reality? Today we're looking at ionizing radiation. An ion is a charged particle. Ionizing radiation is radiation that can be absorbed by atoms and can cause them to become charged up. Ultraviolet, X-rays, and gamma waves are the three types of ionizing radiation that we'll be looking at in today's lesson. What's ultraviolet? The sun emits UV, ultraviolet, every day that we absorb. Ultraviolet radiation is high energy electromagnetic radiation that's found between visible light and X-rays on the electromagnetic spectrum. The wavelength of UV falls in the range of 10 to 1000 nanometers. We can't see UV radiation, but some insects and animals can. Examples are bees, birds, and butterflies. How is UV radiation made? UV is given off by hot objects like the sun. Electrical sparks and arc welding also reach temperatures that are high enough to produce ultraviolet radiation. Some gases emit ultraviolet radiation when an electric current is passed through them. These can be found in tanning beds, energy-efficient light bulbs, and as black lights. In light bulbs, the bulb is coated with a fluorescent coating that emits visible light when it absorbs UV. Appraisers use black lights to detect forgeries of antiques. Many paints today contain phosphors that will glow under a black light, while most older paints do not contain phosphors. Repairmen use them to find invisible leaks in machinery. They inject a little fluorescent dye into the fuel supply and illuminate it with black lights. Black lights can be used to detect counterfeit notes. They can be used to identify counterfeit money. Amusement parks and clubs use them to identify invisible fluorescent hand stamps for readmission, and forensic scientists use them to analyse crime scenes. Is UV dangerous? We need to absorb UV as our skin uses the ultraviolet radiation from the sun to make vitamin D, which we need to keep our bones healthy. Too much is generally harmful to the skin and eyes. Sunburn is our body's response to too much UV. Ultraviolet radiation kills skin cells. Repeated exposure can lead to premature aging of the skin and increases the risk of skin cancer. Intense UV radiation can also aggravate eyes, and long-term exposure may cause cataracts. So how can we limit the exposure we have to UV? Well, wearing big hats, wearing sunglasses, and putting sunscreen on are really important when we're trying to protect ourselves from the UV from the sun. Okay, how about X-rays then? What are X-rays? If you've broken a bone and gone to hospital, you would have had an X-ray photograph taken. X-rays are a type of electromagnetic radiation that can penetrate through lots of different materials well. The wavelength of an X-ray lies between 0.1 and 10 nanometers. How are X-rays made? X-rays are made when high-energy electrons suddenly lose energy. X-rays are produced artificially using an X-ray tube. Electrons from the hot cathode are accelerated across a high potential difference at the tungsten target. When these high-energy electrons hit the target, some of their energy is changed into X-rays. What are X-rays used for? X-rays are very penetrating and can pass through many forms of matter. They're used in medicine, industry, and security to take pictures of inside of objects. Concentrated beams of short wavelength X-rays can be used to kill cancerous cells. X-rays are used to work out the arrangement of atoms in various substances, including crystals. Special precautions must be taken for the person having an X-ray. Only the area of the body being examined is targeted with X-rays. Other areas are protected with a lead shield, which is too dense for X-rays to pass through. To minimise their exposure when an X-ray image is being taken, radiographers must wear a lead apron, stand behind a screen that absorbs X-rays, or even leave the room. One-off X-rays do not pose much risk to health. Radiographers take several X-rays each day, and their potential dose is much higher. So that's the end of our lesson on ionizing radiation. These are the things you should be able to do. You should be able to state examples of ionizing radiation and define the term ionizing. You should be able to describe applications of different types of ionizing radiation, and you can explain the dangers of ionizing radiation. So this was our question at the beginning. Do you think that radiation can have beneficial effects in reality? Well, we use X-rays for many different things, and we use ultraviolet for many different things, which benefit our everyday life. So yes, but can they turn us into superheroes? Probably not, unfortunately. High doses of radiation is probably more dangerous than anything else, and could be very damaging to our health and potentially cause cancer. Okay, so that's been our lesson on ionizing radiation. I've been Mr. Baker, and I'll see you next time. Thanks very much.